Welcome to you all in my YouTube channel Experience Mathematics. Today I am going to teach you conic section, which is one topic of class 12. Conic section. Conic section is the intersection of a plane and a cone. By changing the angle and location of intersection, we can produce a circle, ellipse, parabola or hyperbola. So how the plane cuts this cone, accordingly different types of curves are formed, which are known as conic section. If a plane intersects a cone perpendicular to the axis, then the section is a circle. So if a plane intersects a cone, here is one cone, and if the plane intersects the cone perpendicular to this axis, this is the axis of the cone, and making perpendicular if the plane intersects, then the section is circle. So here let us take one plane. This is a plane, and then this intersect. This will intersect. This making perpendicular means here this angle is 90 degree. Then the section formed here is a circle. Your circle will be formed. So if the angle between plane and the axis of the cone is 90 degree, perpendicular means 90 degree, then the circle is formed. A cone, if the plane intersects a cone at a given angle with the axis greater than the semi-vertical angle, then the section is ellipse. In the similar way, so the same plane, if the same plane intersects the cone at the given angle with the axis greater than the semi-vertical angle, so angle made by the plane with this semi-vertical angle, this angle is greater than the semi-vertical angle, not perpendicular but greater. At that time the section is the ellipse. So this angle, if not perpendicular but it is slanted in this way, and this angle is greater than the semi-vertical angle, then the section is an ellipse. Similarly, if a plane intersects a cone and the plane is not passing through the vertex, and it is without passing through the vertex, if it is not passing through the vertex, and then it is parallel to the generator of the cone. Here this one is called the generator of the cone, because if we draw one axis, and then if we rotate this line around this axis, then the cone is formed. So this one line is also known as the generator of the cone. So if the plane cuts this cone in such a way that angle between this is in such a way that the plane is parallel to this generator, this is called generator. This slant height is also known as generator. Then the section is the parabola. So if the plane cuts in such a way that this plane is parallel to the generator, then the conic section formed is, it is the parabola. So a parallel prefix is para, word is also here, and then in parabola also para, and parallel also par prefix will come. So in that way also we can remember. So this, if the plane is parallel to the this generator, at that time parabola is formed. And if the plane intersects this double cone, if the plane is a double cone, so that the angle between the axis and the plane be less than the same vertical angle, then the section is the hyperbola. So if the plane is cutting this both, and then that angle between that plane and then axis is less than the same vertical angle, this angle is the same vertical angle. If the plane is cutting both the cone, it is cutting double cone, at that time definitely angle will be less than the same vertical angle, and the section formed is called hyperbola. So at that time curve will be found on both sides, in this side and as well as in this side. So that double curve, that is known as the hyperbola. So in hyperbola case, curve will be formed up and then down both, and then this one is called this is the axis of the hyperbola. This way if the plane cuts both the cone, double cone, at the time such type of curve is formed on both sides, and this is known as the hyperbola. And we can also define a conic section in terms of locus. The locus of a point which moves in such a way that the ratio of its distance from the fixed point to its distance from a fixed straight line is constant is called the conic section. The constant ratio of distance of point from focus to the directrix is called the eccentricity. So locus of a point which moves in such a way that the ratio of distance from the fixed point to the distance from the fixed straight line is constant is called the conic section, and the constant ratio of distance of the point from focus to directrix is called the eccentricity. So here we can take one here we can take one fixed straight line and one fixed point. This is fixed point, and making distance equal from this fixed straight line and this fixed point. This fixed point is known as focus, and this fixed straight line is known as directrix. Making distance equal, that ratio of distance from fixed point and fixed straight line constant if the point moves. If the point moves and makes curve, and this curve is the conic section. Here ratio of the distance from this distance and a distance from fixed straight line is taken perpendicular distance, and a ratio of this distance and this ratio of this distance is constant. In that way, if it moves, then the curve is the conic section. The constant ratio of distance of a point from focus to the directrix is called the eccentricity. So ratio of distance, this distance and this distance ratio is known as the eccentricity. A conic section in which the value of the eccentricity is unity is known as the parabola. So eccentricity, I have already explained this. This ratio, distance from fixed point to the distance from fixed straight line ratio, is known as the eccentricity, which is constant. And if this ratio is 1, unity means 1, it is known as the parabola. In the case of parabola, that ratio will be 1. That ratio equals to 1 means it is equidistant from fixed point and fixed straight line. No equal to, I have cancelled this, it is misprint. Okay, a conic section in which value of eccentricity is less than unity. A conic section in which the value of the eccentricity is less than unity is known as ellipse. In the case of ellipse, the value of the eccentricity is lesser than 1. This ratio, this distance from fixed point to the distance from fixed straight line, this ratio is lesser than 1 in the case of ellipse. That is, eccentricity value is lesser than 1. A conic section in which value of eccentricity is greater than unity is known as hyperbola. So here value of eccentricity is greater than 1, it is bigger than 1, and generally this will create confusion to the students during examination, because they have to prepare many things, and they may forget whether eccentricity value is bigger than 1 for hyperbola or lesser than 1 for hyperbola. They may be confused, and sometimes they may write wrong also. For ellipse they may write bigger, and for hyperbola they may write smaller. For not to be confused, what can be done is that here prefix that hyper we can use here. So this hyper meaning is excessive, just like that hypertension means high blood pressure. Okay, so hyper meaning is excessive, more. So excessive or more means here value of E is also more than 1. So that link we can make in our mind, so that this eccentricity value greater than 1 will not be forgotten, and if it is bigger than 1, definitely it is lesser than. For ellipse it is lesser than 1, one bigger than another one is smaller, so it can be remembered easily. And this parabola eccentricity equals to 1 is not difficult to remember. And now here one parabola we have. So here we have to define parabola. The parabola is the curve formed from all the points that are equidistant from directrix and the focus. So this straight line, it is the directrix, and this point is the focus, and this point on the parabola is equidistant, is it equal distance from focus and from directrix. So if the point moves making distance equal from focus and directrix, then the curve is known as parabola. So the two definitions are same, that eccentricity value equal to 1 or this equidistant, both is same, because if this PF and PM, distance from fixed point and fixed straight line, are equal, ratio of this PF over PM will be 1. So from both we get the same conclusion. Now next, that is the focal distance. The distance of any point on the parabola, distance of any point. This is one point, or maybe another point. So any point on the parabola from the focus is called the focal distance. So here this PF is focal distance. Similarly, if you take any other point, then this is focal distance. This OF is also focal distance. Like the distance of any point on the parabola from the focus is called focal distance. So next, that is the focal chord. Any chord of the parabola, any chord of the parabola passing through the focus is called the focal chord. So here this PF P dash, this is passing through focus, so this is focal chord. Similarly, this LF L dash is also focal chord, because this also pass through the focus. So any chord passing through the focus is called the focal chord. So next, that is the latus rectum. The focal chord which is this focal chord which is perpendicular to the axis, this is perpendicular to the axis, is called the latus rectum. Here LF L dash is the latus rectum, because it is perpendicular to the axis of the parabola, and it is passing through focus as well. So equation of the parabola in standard form. Okay, so here I will do correction here. So in this it's not square here. Here y square equals to 4x, equation of parabola in standard form is y square equals to 4x. This we will derive. Equation of parabola in standard form. To determine equation of parabola in standard form, we take vertex at the origin. This origin is the vertex, and focus F on x-axis. This is x-axis. Here we take focus on x-axis. So this is x-axis, and this is, we have taken vertex at the origin. So this y-axis is tangent at the vertex. To determine equation of parabola in standard form, we take vertex at the origin. Here we have taken vertex at the origin and focus F on x-axis, so that the axis of the parabola is the x-axis and directrix is parallel to y-axis. So here axis and directrix, they are perpendicular to each other, and coordinate of F focus is a comma 0. This is a step right from the vertex, so its coordinate is a comma 0, and the equation of the directrix is x equals to minus a, so x plus equal to 0. So here it is a step left from the origin, and we know that equation of the straight line parallel to y-axis is equals to x equals to a, but here in place of a we have minus a because it is a step left. So equation of directrix is x plus equals to 0, or we can also write this as x equals to minus a. So its equation we can also write as x equals to minus a, because we know that equation of straight line parallel to y-axis is x equals to a, but in place of a we have minus a, so equation of directrix is x plus a equals to 0. Let pxy be any point on the parabola. We take any point pxy on the parabola from which pm perpendicular to this directrix is drawn, and this OF equals to a. Then the coordinate of this m coordinate will be here, it is perpendicular, okay, this is perpendicular, so m coordinate will be, it is a step left, so x coordinate minus a, it is y step up because it is perpendicular, and this is also perpendicular, so this is y and this is also y, because this is the rectangle, so opposite sides of the rectangle are equal, so this is y, then this is also y. So the coordinate of the point m on the directrix is minus a comma y, and we will join this pf. Then by definition of the parabola, this pf equals to pm, because we know that the any point on the parabola is equidistant from fixed point and fixed straight line according to the definition of the parabola. Parabola is the locus of the moving point which is equidistant from fixed point and fixed straight line. So pf and pm are equal. So equation of parabola I have continued here, and now here pf square equals to pm square. So in this previous slide here I have written that pf and pm are equal, so pf and pm are equal, and so if we square this pf equals to pm, then pf square equals to pm square we can write, and using distance formula, this pf square is the square of the distance, so distance formula is d equal to root over x2 minus x1 square plus y2 minus y0 square over, and root over to that, we know that. distance formula D. Distance formula D formula is, that is root over x2 minus x1 square plus y2 minus y1 square. We have this formula. This is the distance formula for the 2 points x1 y1 x2 y2, distance between 2 points x1 y1 x2 y2. So using this formula here, as this is the square of the distance, so this square root will be removed while squaring. So in place of x2 we have x minus x1 is a, y2 y minus y1 is 0, plus here x2 is x, and here minus x1 is minus a at square, plus y2 is y minus y1 is that y at its square. And when you simplify this, here using a minus b whole square formula, we can using a minus b whole square formula, we can expand this x square minus a minus b whole square formula, a square minus 2ab plus b square. 2a means x, b means a, plus b square, a square, plus y minus 0 is y square, plus using a plus b whole square formula, a plus b whole square formula is a square plus 2, in place of a we have x, in place of b we have a plus b square. A plus b whole square formula is a square plus 2ab plus b square. Using that we can get this. Y minus y is 0, so 0 square is 0, so it's written as it is here. And now in this both sides, this x square and x square can be cancelled, because x square comes here and becomes minus x square, so this x square can be cancelled on both sides. This x square here and then x square on this side, this can be cancelled. Similarly this a square can be cancelled with this a square, and now this y square equals to this 2x, and this minus 2x goes to other side and becomes plus, so y square equal to 4x. This is true for any point on the parabola, hence it is the equation of the parabola. So this is the standard equation of the parabola, or equation of the parabola in standard form. In this way we can easily derive the equation of the parabola. Finding out the equation of the parabola derivation is also important for the exam point of view. Thank you for watching my video. I hope that this video is helpful to you. Please don't forget to subscribe my channel. Thank you very much.